We have some discussions over the Open RAN architecture and the Open RAN intelligent controllers. So in this webinar, we will try to cover a most important but the vast topic of 5G, that is called network slicing. Basically, 5G network slicing. So what is network slicing? Network slicing is basically it's a logical network basically that provides the kind of network capabilities and the network characteristics which we are able to get from the traditional network or from the 5G network itself. So in the basic terms, network slice is nothing but a logical part of the total network that has been designed by the operator in order to serve the different use cases of the customer, different use cases of the some business entities. So it's basically a slice of a complete network. The slice sometimes can be belongs to the RAN part only, sometimes can be belongs to the transport part, or sometimes it can belongs to the core part, right? So from the other monology we can understand the network slice. It's a part of something that is being dedicated for some specific task, right? So, in order to understand the network slice more, we need to understand some more basic terms which are there in terms of in a network slice. So, there is a term called NF. NF. NF is basically a network function. So, in our earlier webinars, we try to understand that 3GPP release 15 has suggested a way to disaggregate the RAN part into the two different parts. Those parts are known as the centralized unit and the distributed unit, right? So those centralized unit, distributed unit, remote units or RUs are known as the network functions. And since those units will be created on the cloud as a virtual machine, so those are known as the network instances in terms of virtualization, right? So in the term in the term or in the language of software, those individual functions are known as network functions. And those network functions like the CU, DU, and the RUs are completely provide the end-to-end service. And that end-to-end service is known as a network service or a NS. So network service is basically a kind of service that has been extended from 5G core, 5G RAN, and the UE part. So it means that network service is an end-to-end service, right? There are some considerations in order to follow by the operator when the operator is going to look for the network slice deployment. So since network slice may differ for the different kind of features and the different kind of network function optimizations. So as we know that 5G has been designed in order to provide a different kind of services, like the operator can provide a EMBB, operator can support for EUR LLC, or operator can support for IoT as well. So operator can design a network slice in order to support these different kind of use cases. Since these different use cases will require different KPIs in terms of latency of the network, in terms of the availability of the network, and in terms of the throughput which has been provided by the network. So based on these different measuring attributes, network operator can design the network slices. And network slices, of course, at any point of the time can differ from the same service. For an example, let's say if the one particular operator is supporting one business entity to serve their users on a broadband service, right? And there is also a second entity for which the operator is providing a broadband service. So the operator can design network slices for these two different entities which are serving the same services or providing the same services, but the QO quality of services sets which are applied for these users or for these entities may be different, right? And uh, this network slicing concepts basically formalized or generalized by 3GPP in release 15. So of course it will cover a variety kind of use cases, and it will provide a huge kind of benefits to the operator when they are providing a network slices to the business entities or some other entities as well. So here we can see that 5G network slice or just a network slice is being designed by 3GPP, and all the signalings, all the architecture and all the resource management terms and sub-terms for this end-to-end network slice are being defined by 3GPP as well. So when we talk about the signaling, all the signaling which is there for the layer 3 messages, which is there for the RRC messages or some other layer 2 messages are defined by 3GPP. And the negotiation assignment of NSSAI. NSSAI basically is a network slice selection assistance information. So basically is a unique ID which we'll discuss into later into the slides. So this, this is kind of signaling which is basically defined by 3GPP as well, and different kind of interfaces which are already there in the definition of 3GPP for 5G, like the NR-UU interface, N1, N2 interface, and some other interfaces, right? So these are all interfaces are defined or generalized by 3GPP under the umbrella of signaling. And if we talk about for the end-to-end network slice architecture, then of course it is also been defined by 3GPP. The architecture of the network slice will of course be based on a cloud native architecture in which the different network entities will be created as a virtual machine on a cloud. So each virtual machine will have their instance and will provide a one kind of network function, and this all these network function will form a complete network service for that network slice, right? So other kind of software architecture and introduction of NSSF. NSSF is basically a function which basically provides a definition for network slice. So this, I mean, the abbreviation of this NSSF is network slice selection function. So this basically is a logical unit which is there. If you look at the 5G architecture, then this unit is there, logical unit is there, and this unit basically provides a way to form a network slice end to end. And third term is the network resource management. So of course, network resource management is required for everywhere, whether it's legacy technologies of 2G, 3G, 4G, or it's 5G. So it's also there in the 5G for the network slice, and it's been defined by the 3GPP as well. So all kind of quality of service policy enforcement, all kind of radio resource management, and all kind of layer 1 and layer 2 algorithms, whether those algorithms belongs to the scheduling of different users, whether those algorithms based on providing a multiplexing or demultiplexing of the users, right? So all these algorithms, all these radio resource management algorithms are being defined by 3GPP as well. Now, if we look at this picture, this is basically a end-to-end network slice for the legacy versus 5Gs, right? 5G system. So if we talk about the legacy system, for an example, let's say 4G, then of course 4G was designed to provide the mobile broadband service only, or MMBB only, right? And there was no other use cases in the 4G like the like URLLC or IoTs. There was no such use cases was defined by the 3GPP during the development or development of 4G. So when we talk about the 4G, we can see here that all the spectrum, whether it's whether it can be any frequency, all those spectrum is just available for one service that is called MBB only, right? Mobile broadband only. And if we talk about the architecture from the RAN perspective, from the core perspective, from the transport perspective, then all those all those kind of infrastructure was just available for these services only, like MMBB, and the underlaid services are as SMS, and the if the operator deployed the IMS, then this architecture or this complete ecosystem can also provide voice services also. But there was no segregated network of any unit, right? Here is a complete units are available to be used by these use cases only, like MBB, SMS, and the voice. But when we talk about the 5G system, since 3GPP has already defined that concept of network slice, so here we can see that there are the different use cases like the EMMB, enhanced mobility broadband, smart factory or robotics. These use cases are comes under the category of URLLC, ultra reliable low latency communication, right? Or V2X. And these smart factories, right? These smart factory are comes under the category of massive MIMO, massive machine type communication, or massive IoTs, right? So these are the different use cases which are there when we talk about the 5G. And in order to serve these use cases, through GPP defined the concept of network slicing. So here we can see that, for an example, let's say this complete slice has been created by the operator in order to serve the use case of EMMB. So here we can see that at the core network, there are different logical network entities has been created, and these are called like CNF, containerized network function, and RNF. So these are the different network functions which are there. These network function can have a different name, like these can be the virtual network function, these can be the physical network function, or PNF, right? So this concept of network slicing on a cloud native network will once again based on how the operator going to serve or provide the network slice to the business entity or to the end user. Here in a second slice is being provided for the smart factory, right? So in the smart factory there can be multiple smart sensors or smart robotics as well. So multiple things can be happen on this logical network. The most important thing here to note is that these all logical network, like logical network 1, logical network 2, and the logical network 3, are based on shared physical network, right? So the physical network is shared by these different logical networks, and these logical networks are once again based on cloud native form, right? And these cloud native forms means that all the network function, whether it's CU, whether it's DU, or whether it's RU, it's been defined on a virtual machines. Now here we can look at RAN slice function. I mean, here is a network slicing picture which is based on the RAN part only. So in the first example here, two slices created by the operator, in which we can see that there are two different kind of a spectrum are there, and this is, I mean, slicing has been happened from the physical layer to the upper layers, right? So whether it's physical layer, there are two different slices, whether it's MAC layer or RLC layer, or the PDCP or the RLC layer, all all the layers has a different segregated part, right? And if we talk about for the second picture or the second example here, here the operator provided a one spectrum, so there is only one frequency, right? But the numerology, which is in case of 5G, are different for the different use cases. But at the MAC layer, RLC layer, PDCP, and the RLC layer, they are other the different slices or the different separate entities for each of these service, right? So I mean, in a similar way, like in a third example, this one, again the spectrum is the same, and at the physical layer different numerologies are there, but at the MAC layer some functions of the MAC layer are shared, and some functions of the MAC layer are are common for the both slices. So that's why it is designed in a box. And for the others layers like the RLC layer, PDCP, RLC layer, these are the having a different entities for the these two slices respectively. And for the last one, here is the spectrum is same. All the functions of the physical layer are same for slice 1 and slice 2. And if we talk about the MAC layer, then MAC layer is also common for slice number 1 and slice number 2. However, the RLC layer functions, PDCP layer function, and RLC layer functions are segregated for the slice number 1 and the slice number 2. So this is once again the another concept here. Here is a example of the RAN slices, which are based on the different layer functions. For an example, like physical layer do the coding, turbo coding, convolution coding, multiplexing, etc., right, for any signal. So here if we look, if we take an example like operator has provided a slice for a IoT, and then how these layer will look like for that particular slice. So I mean the physical layer function will of course provide a coding kind of functions. And of course, the physical layer functions will be provided or optimized in such a way so that it can cover uh, or it can provide a major coverage area, so that it can fulfill the needs of IoT applications. And sorry, if we talk about the MAC layer, then of course MAC layer, the HARC functions, scheduling functions are happened at the MAC layer. So HARC optimized for this IoT applications. And if we talk about the RLC layer, then the RLC layer will behave as unacknowledged mode, so that there won't be any kind of responses from the end devices, right? And if we talk about the PDCP layer, then of course there will be a massive number of devices when we talk about the IoT. So the PDCP layer functions like the ciphering and the header compression would be omitted, so that these layers can save a much part of its bandwidth, right, in order to serve more and more number of devices. Of course, in case of IoT, there won't be any kind of mobility in the sensors, or in kind of I mean to whatever kind of IoT applications are there, there won't be any kind of mobility. So that's why all kind of handover measurement events omitted from the RRC. So of course, this slice will when the operator will deploy their network slice in order to serve IoT application or MMTC, then these layers like the RLC layer, RLC, PDCP, RLC must need to be designed in such a way so that these can fulfill all the requirements of IoT. And in a similar way, the RC layer, PDCP layer, and RLC, MAC or physical layer has been designed in order to serve this is a number. For an example, let's say this is a slice number 1, this is slice number 2, and this is number slice number of 3. So in a similar way, like the operator designed these layers for the IoT, the operator must need to design their network slice and the different layers of the model when the operator is going to provide a service of EMMB and when the operator is going to provide a service of URLLC. So there are, different key concepts in the 5G or in the network slicing. So these concepts are, further categorized as a slice identity management. What kind of slice is there? What are the function of the different slices? How the resource management will happen, and what is the availability of the slice in the 5G network? How a UE or the AND device will support a different or multiple slices, and how the slice will be validated at the UE and at the network point. So we will discuss those here now. So first is the slice identity management. Slice identity management is basically defined by this term that is called as a single network slice selection assistance information. So this basically is a term or is an attribute which basically defines that what kind of slice is there and how can the end user or the UE can know that from which information it can decode that what kind of slice is there. So basically NSSAI basically constitutes two terms. Those are known as the SST, slice service type, and the slice differentiator, right? So once again, if the NSSI is a standardized type, then it will has right, SST only, and there won't be any SD or the slice differentiator. But if there is a NSSI is a non-standard type, then of course it will constitute the SST and the service differentiator. So both will be there, and these are the values for the service or slice type for the different slice for the different use cases. So when an RF engineer or you will work on the network slicing, then of course then you will see that for EMB the SST value is 1, for URLLC SST value is 2, for IoT SST value is 3, right? And if we talk about the different type of NSSI, then these are the subscribed. Subscribed means the NSSI identity is already stored in the UDM. UDM basically equivalent to HS home subscriber server in case of 4G, and it is stored all the NSSI, right? And there is a configured NSSI, and there is a allowed NSSI, requested NSSI, rejected. So these are the different technical terms which comes into the picture when the UE is going to when the UE is going to support that particular use cases, and so that UE will be able to identify from those identity that what kind of slice it is going to be served by, right? So here is the next next technical terms. For example, the end-to-end slice awareness. So end-to-end slice awareness, it means that the UE or the end device must be aware that what kind of slice is there, or if the slice is basically is there till the RAN part only, or the slice is also extended or by to the RAN part, to the transport part, to the core part as well, right? So the slice awareness basically will happen based on the different quality of services attributes which will be provided to the UE by some layer 3 messages when the UE will try to attach with the network, right? So since we know that there are different quality of service profiles are there with respect to the every kind of service, whether it's a non-guaranteed bitrate service or the GVR service. So based on those services, it will provide that information. right? And the selection function basically, like, how the UE will select the particular AMF or AMF is basically an entity in the 5G architecture, which is basically equivalent to MME in case of 4G. So how UE will select a particular AMF, and how UE will retain to that AMF for the particular slice interval or for the particular service cycle. So that will those processes are defined here in the selection functions. In the resource management functions, all the all the policies, all the attributes which are related to the resource management for that particular slices are defined here only. So in a similar way, there are the slice availability in the 5G system. So if there are slices available on a particular registration area or the tracking area, or if the slice is available throughout the network, this will identify here. And the multiple slices support means that the UE can be able is able to support a multiple slices at a time. For an example, 3GPP says that a single UE can support 8 slices at maximum at particular point. So how the coordination between different those slices happen, and how UE will behave under multiple slices. So all those policies, all those information has been defined under this multiple slice support. And in the UE slice validation, in this category, the the kind of slices there is being what kind of slice has been allocated by the network to the UE will be supported or will be defined under this category. So of course this is all about the network slicing. I mean, this is basically a brief knowledgeable session or webinar for the network slicing. Of course, network slicing is basically a broad, it's a vast topic, and of course need a more and more time to study, more and more time to focus. But I mean, if we look at the current timing and around the world, then we can see there are only a couple of operators who are working on network slicing, since network slicing will of course need a support of 3GPP release 16 version. So that is all for the today's webinar. If there are any questions, please do let me know.
Thank you, Jitendra. We have one question from Facebook. It says, what is the difference between network slicing and quality of service?
Okay. Network slicing and quality of service. So basically, network slicing and quality service are basically, there is a thin line difference between these two terms. However, network slices are basically designed by the operator to serve the different business cases which weren't able, which the operator weren't able to support with the quality of service kind of thing. So with the network slicing, operator will support 5G different use cases. It will support a different business entities. It will support different users as well, right? But with the quality of services or QoS, the operator was just limited to the some kind of use cases of mobility broadband only. So network slicing basically provide a benefit of right, business use cases as well as some other technical advantages to the operator.
Well, thank you. Thank you, Jitendra. We have one more in our
Mhm.
email. It says, what are the benefits of network slicing to operators?
Yeah, I mean, of course, network slicing will, pose a great benefit to the operator, since, with this network slicing, operator will serve different needs of the different entities. So let's say one entity that is working on a smart factory automation, then operator will provide a one one but particular physical line which is based on the network slice for that business entity. And there can be, in this similar manner or in the similar fashion, there can be multiple business entity which will have their own set of requirement of the network. So operator will be able to serve these different business entity based on their requirement, and of course will get benefit from them.
All right. Thank you, Jitendra. Well, those are the questions that we have for today's webinar. I want to thank you
Mhm.
all for joining in, and stay tuned for future webinars. Thank you, Jitendra, and thank you all.
Thank you. Thank you,
Thank you.
Gabriel. Thank you, everyone.
Have a nice day.
Have a nice day, everyone.